Here are the answers to the first year singles mock exam for 2018. In question 1, we've got 4 equals 64 to the power n. 4 cubed equals 64. So let's take the cube root of each side. Therefore 4 equals 64 to the power 1/3. Therefore n equals 1/3. In part B, we've got the square root of 50, and the trick is to write these numbers as a multiple of a square number. 25 times 2 is 50, so that's the square root of 25 times the square root of 2. The square root of 25 is 5, so that's 5 root 2, therefore k equals 5. In question 2, we've got to spot the errors. The first error is in the second term. It's 3 over root x. 3 over root x means 3 over x to the half, which is 3x to the minus a half, not 3x to the half. The second mistake is in the evaluation of the integral. So we've got x to the power 4 minus 3x to the power half, sorry, minus a half, that was a mistake, wasn't it, plus 2 dx, and we've got to do that between 1 and 2. So if you integrate x fourth, that's a fifth x to the power 5. Integrate minus 3x to the minus a half, you get 6x to the half, and integrate 2, that's 2x. So that's between 1 and 2. Now one of the mistakes they've made is they've done this in the wrong order. What we should do is put in 2 first, so that's 32 over 5 minus 6 root 2 plus 4, and then put in 1 second, so that's 1/5 minus 6 plus 2, and that works out to be 5.71. So the second mistake was doing it in the wrong order. I've got to put 2 in first, 1 in second. And then obviously their mistake here got carried through here, which is why these terms ended up wrong. But the correct answer is 5.71. In question 3, we've got f of x equals x cubed minus 5x squared minus 2 plus 1 over x squared. So let's differentiate because we need to find the gradient. So that's 3x squared minus 10x, 2 differentiates to 0, and 1 over x squared, that's x to the minus 2, so that becomes minus 2x to the minus 3. When x equals minus 1, then the gradient, if you substitute minus 1 into that expression, then you're going to get 15. And the y value, the f of x, if you put in minus 1, you get minus 7. So the gradient of the normal is the negative reciprocal, which is minus 1/15. So using y minus y dashed equals mx minus x dashed, you get y minus minus 7 is minus 1/15, that's an equal sign there, x minus minus 1. You need to go on to the next page. So y plus 7 multiplied by 15 is minus x minus 1. This works out to be plus 1, there's a minus sign there, minus times a plus is a minus. So 15y plus 105 equals minus x minus 1. What format have we got to get it in? ax plus by plus c is 0. So x plus 15y plus 106 equals 0. For question 4, we've got g of x is x minus 2 squared x plus 1 x minus 7. So let's sketch the curve x and y. It's a node, it crosses the y-axis when x is minus 1 and when it's 7, and we know that at 2 it touches, because it's x minus 2 squared, it's a squared there, it doesn't go through there, it touches at that point. So generally the graph does this. That's not terribly good with my finger on the iPad, but generally it does that. So this point here, it should be touching. There shouldn't be that gap there. Now in part B, we've got to write down the roots of g of x plus 3. Write down means it's easy. So the whole graph is translated 3 units to the left. So the roots are going to be 3 less than what we've got here. So it has roots equal to 4, minus 1, which is a repeated root, and minus 4. So I've taken 3 away from 7 to get 4, 3 away from 2 to get minus 1, 3 away from minus 1 to get minus 4. Remember that this graph, g of x plus 3, is the whole graph translated 3 units to the left. Now question 5, we've got to solve this equation. Probably easiest to write everything in terms of 3, because 3 squared is 9 and 3 cubed is 27. So it's 3 squared to the 2x equals 3 cubed to the x squared minus 5. And when you get powers of powers, you can just multiply them together. So 3 to the power 4x is 3 to the power 3x squared minus 15. So powers of powers, 2 and 2x, 4x. So now we can just equate those powers, so therefore 4x equals 3x squared minus 15. And make a quadratic there, 3x squared minus 4x minus 15 equals 0. Let's hope it factorises. It's going to be 3x and x. 5 3's are 15. So let's put 3 there and 5 there. And we'll have minus 9 plus 5. So therefore x is 3 or minus 5/3. Right, question 6, we've got to solve this equation. We've got a cos and we've got a sine, but let's use the main way of converting from sine squared to cos squared by remembering that sine squared is 1 minus cos squared. So 31 minus 25 cos x is 19 minus 12 plus 12 cos squared x. Let's make this into a quadratic. I've got 12 cos squared x. I'm going to have plus 25 cos x, and I've got 7 there, minus 31, so that's minus 24 equals 0. Unfortunately this doesn't factorise, so let's write cos x is minus b plus or minus the square root of b squared minus 4ac. 4 times 24 times 12 works out to be 1152. But notice that there's c is minus, so b squared minus 4ac turns out into a plus. That's lucky, otherwise there'd be no solutions. And it's all over 2a. So one of the solutions here is 0.7148, and the other solution is minus 2.7981. Now cosine can't be minus 2.7981, maximum cosine is 1 and minimum is minus 1, so we've got to solve the equation cos x is 0.7148. So if we do inverse cosine of 0.7148, what are we in? We're in radians, so I get 0.77, and from the cosine graph, let's do a tiny little graph here, I've got the principal value to be around about here, so the other value is there, it's 2 pi minus that, and 2 pi minus 0.77 is 5.51. And the question was to 2 decimal places. Now, question 7 looks like a mechanics question, but it isn't. It's a pure maths question. Part A asks you to rewrite it in the form like you normally do for completing the square. That minus 0.01 is a bit irritating, so let's get rid of that 0.01 and write it as x squared, and then it's minus 22x, and it's minus 158 divided by 0.01. I'll get those numbers. So let's carry on. 0.01, I'm going to have 2 brackets now. It's x minus 11 squared, because half of 22 is 11. So I've put in 121, I've got to take away 121 and take away 158. So that's minus 0.01, x minus 11 squared minus 279. So let's now multiply out the brackets. Minus 0.01 times minus 279 is 2.79 minus 0.01 x minus 11 squared. So this was part A. Let's look at part B. We've got to find the maximum height. So we've got 2.79 here, and we're taking something away from that. So to get the maximum value of the whole expression, we want to take away the smallest possible amount. The smallest value of x minus 11 squared is 0. So 2.79, take away 0, we're going to get 2.79. So the maximum value is 2.79, and it occurs when x equals 11. When x is 11, that's 11 minus 11 is 0, so it's taken away nothing. The fact that that's squared means that the minimum value of this whole expression is 0. Now in part C of this question it says how far from goal is the football when it is kicked. Well, when it's kicked, the y value has to be 0. So when y equals 0, we get minus 0.01 x squared plus 0.22x plus 1.58 equals 0. We could solve that equation by using the formula, but we've already put it into completing the square form, so let's use that as 2.79 minus 0.01 x minus 11 squared equals 0. So therefore 2.79 must equal 0.01 x minus 11 squared. Divide by 0.01, so 279 is x minus 11 squared. So let's take the square root of 279, which is 16.703, equals x minus 11. That's obviously plus or minus. So therefore x is either 16.703 plus 11, or minus 16.703 plus 11, which is negative. So I'm going to say since x is positive. Now in part D, let's see what happens when the ball actually gets to the goalkeeper. When it's at the goalkeeper, x equals 0. So when x equals 0, we can say that y is 1.58 just from the original expression. So when x is 0, when it's at the goal line, it's 1.58 meters high, which is over the height that the goalkeeper can save, but it's under the height of the goal. So since 1.5, which is the goalkeeper, what the goalkeeper can save, is less than the height of the ball, which is less than the crossbar at the top, which is 2.44, so since that, it's a goal. There we are, it's a goal.